In this lesson, we're working on 4.OA.4. This is the last part of that standard, which is prime and composite numbers in the range of 1 to 100. With this standard, it leads back to knowing the whole part of 4.OA.4. Of course, understanding factor pairs. Of course, that means a good understanding of divisibility rules, as well as those multiplication facts to be able to figure out which numbers are prime and composite. So to understand what exactly is a prime number is one that has only two factors. Okay, and a composite number is a number that has three or more factors. Okay, so that leads us to to be able to determine if a number has only two factors or if it has three or more factors. We need to know, we need to be able to know multiplication facts, and we need to know our divisibility rules, and all of these pay off in order to be a better math student, especially in regards to the number sense of prime and composite. Okay, so let's do, for example, let's just think about the list of prime. We're going to do 1 through 50, so let's do in the range of 1 through 50, let's do prime numbers. Okay, so we'll do prime numbers that are in the range of 1 to 50. So, and the one thing that I always tell students as well is that the digit 1 is neither prime nor composite. It's the only number that's neither prime nor composite because it doesn't follow either of the rules, because it only has one factor, and that number is 1. And we don't, if it's a digit that's multiplied by itself, we don't count each digit, the same digit, twice. So, knowing that prime numbers have only two factors, one in itself, and the only even number, another thing that tells students, the only even number in all numbers that is prime is the digit 2. So when we're starting, if we start at the bottom with 1 and thinking about our numbers which are prime, which are composite, we know that 2 is the only even number that is prime because it has two factors, that is 1 and 2. Okay, and so of course 3 is a number that has only two factors. The only way you can make 3 is by 1 times 3, so that makes it prime with only two factors. If we go down and make a composite list as well, we're going to know that 4 would be composite because it has 1 times 4, and it has 2 times 2, so that gives it 3 factors, which would make it composite. And the number 5 would be prime because the only numbers that multiply to make 5 are 1 and 5, so it has only two factors. The number 6, again, it's even, so all even numbers except for number 2 would be composite. All even numbers except for 2 are composite. And so next is 7. Again, 7 is one of those prime numbers that has only two factors, 1 and itself, 1 and 7. And 8 is even. Of course, all of our even numbers will be here. The number 9 has 1 and 9 and 3 and 3, so that gives it 3 factors to make it composite. The number 10 is even, so of course it goes composite list. 11, another odd number that it has only two factors though, 1 and 11, so it makes it prime. 12 is even, so it's composite automatically. 13, another prime number because it has only two factors, 1 and 13, not divisible by any other number. Next is 14, even number, so we know it's composite. 15 ends with a 5, so we know it is divisible by 5, so that gives it the factors of 1 and 15 and 3 and 5, so it goes in our composite list. 16 is even, so we know it goes here. 17 is another one of those odd numbers that has only two factors, 1 in itself. It's not divisible by any other number. 18 is even, so it would go in our list. 19, another odd number that would fall on the prime list, has only two factors, 1 and 19. 20 is even, so therefore, of course, it's composite. 21, even though it's an odd number, it does follow the pattern. If the two digits add up to a sum to be a multiple of 3, then it is 3 it's divisible by 3, and of course 2 plus 1 makes 3, and 3 is a multiple of 3, so that makes 21 composite because it has the factors 1 and 21 and 3 and 7. 22 is even. We go in our list. 23, it is an odd number, but it does not follow any of the other patterns in the divisibility rule, so that makes 23 a prime number. 24 is even. 25, and it ends with a 5, so I know automatically it has 1 and itself and 5 times something, but we know it's 5 times 5, so it gives it 3 factors. 26 is even. 27, if I think about 27, it has 1 in itself, that makes 2 factors, but because if I add up the 2 digits of 2 and 7, that makes a total of 9, and 9 is a multiple of 3, making 27 composite. 28 is even. And 29 is one of those numbers. If you add up the digits 2 and 9, that's 11. You can't divide that by 3. It's not an even number, so that is another example of a prime number with only 2 factors. And we can keep going on and on. 30 is composite. It's even. 31, another odd number. It's not divisible by 3. Doesn't follow the pattern for 3. It is not divisible by 4, of course, because it's an odd number. It doesn't end with a 0 or a 5, so it's not divisible by 5. And so it doesn't follow any of the patterns, so we would go, so 31 would be here. We'll just go in and fill in a few more primes. So 32 would be in the composite list. 33, we know those double-digit numbers are always divisible by 11. So, but 33 in this case, the 2 digits add up to a total of 6, which makes it a multiple of 3, which makes it divisible by 3. So 1 in 33 and 3 in 11. 34 is even. It would be composite. 35 ends with a 5. It is composite because it has 5 as a factor. And so all the even numbers. So we'd get to 37. Once we get to 37, it is does not follow any of the other divisibility pattern rules, so it would fall on our prime number list. It has only 2 factors, 1 and 37, the only way to make 37. And then 38, even number composite. 39, if we add up the 2 digits of 39 is one that often gets students, because if you add up the 2 digits of 39, we get 12. We know that 12 is a multiple of 3, so that makes it divisible by 3, 3 and 13. So 1 and 39 and 3 and 13, that would fall on the composite list. And 40 is even, so it's composite. And 41, another one of those numbers. We add the digits together, we do all those things, follow all the checks, and it is not divisible by any other number, so 41 is prime. 42 is even, it was composite. 43, another number that doesn't follow any of the divisibility pattern rules, so it is prime as well. 44 is even, it's composite. 45 ends with a 5, that makes it composite. 46 is even, makes it composite. 47, the next number that follows our pattern. It does not fit into any of the divisibility rules, so it would be a prime number. It's only divisible by 1 in itself. 48 is composite, and 49, even though it's that odd number, it falls into that pattern of the 7s, because it is divisible by 1 in 49 and 7 times 7, so that gives it 3 factors to make it composite, and that leads us to 50, which is an even number, which is also composite. So hopefully that helps, just giving you some examples of prime and composite numbers and how to think through using those divisibility rules to help you to determine if a number is prime or composite. Just practicing and your child using their hundreds chart, any of those tools to assist them as well. Hopefully this has been a helpful video.